it just becomes impossible if you don't understand the fundamentals, right? And like when people talk about debugging tools, sometimes they talk about like, like observability tools or like debuggers, and that stuff is really great and so important, and I love it. But like if you don't understand like the fundamental concepts about how the system works, it often is really hard to make progress. And the flip side is if you do, like it becomes just like so much easier, right? Because you can think through in your head like, okay, how should this work? Like what are the steps here that are like happening on the computer? And it like gets a lot more straightforward.
Welcome to the Software Misadventures podcast, where we sit down with software and DevOps experts to hear their stories from the trenches about how software breaks in production. We are your hosts, Ronak, Austin, and Guang. We've seen firsthand how stressful it is when something breaks in production, but it's the best opportunity to learn about a system more deeply. When most of us started in this field, we didn't really know what to expect, and wish there were more resources on how veteran engineers overcame the daunting task of debugging complex systems. In these conversations, we discuss the principles and practical tips to build resilient software, as well as advice to grow as technical leaders.
Hey everyone, this is Ronak here. In this episode, Guang and I speak with Julia Evans. Julia runs a programming zines business called Wizard Zines, where she creates comics about various programming concepts. She has been creating zines when she was still a software engineer at Stripe. Her zines are extremely approachable and highly educational. I've bought many of them myself and encourage you to check them out at wizardzines.com. In addition to creating zines, Julia is a prolific blogger and has around 500 posts on her blog at jvns.ca. Her blogs are another great source to learn about fundamental programming concepts. We had a lot of fun speaking with Julia for this episode. We discussed 2 bugs she came across at Stripe. We talk about how she identified and fixed a bug in Kubernetes Scheduler, and how her understanding of TCP helped her fix a performance regression. We also cover other topics like logging, zines, debugging, and learning new things. Please enjoy this fun conversation with the amazing Julia Evans. Julia, we are super excited to talk to you today. Welcome to the show.
Thanks so much for having me.
So I thought we would start with asking you about a word that I've only seen in the Urban Dictionary, which is also your Twitter handle, B0RK. I think Bork is the right pronunciation. And we're wondering if you could tell us the story behind how it became your Twitter handle.
I think it's the normal story, which is I thought it was funny when I was 14. And here we are.
It is unique, and we all recognize you by that these days. And a lot of people also know you through your blog and your zines, which personally I'm a huge fan of. And it's something we definitely want to get into. Before we go there, can you tell us about your engineering career in tech and how you got into the infrastructure engineering space?
Yeah, definitely. So I think when I started out, I worked on Drupal. I made websites in Drupal, and then I worked at like a machine learning consultancy for a little bit, where we didn't have any clients. And then after that, I spent some time at the Recurse Center, which is this program in New York where you spend 12 weeks trying to become a better programmer. And when I was there, I was like, okay, I'm not going to do web design and I'm not going to do machine learning because I kind of know something about that. And instead, I wanted to do something that I didn't know about. So I spent a lot of time trying to learn about operating systems, and I tried to write an operating system, and like I wrote like a little TCP stack it did work in an extremely limited way. It was in Python, which is the perfect language to write a TCP stack in.
Yeah,
as we all know.
But it sounds hard though.
It wasn't that hard. It was okay. The hardest part was getting it to actually send a TCP packet. Once I could send one packet, it was okay.
Nice.
And so I started learning about the system stuff there, which previously kind of seemed really unapproachable to me. And I was like, oh, this is so fun. And I loved it. And then I got another job doing machine learning, which is not system stuff at all. Because I was like, well, my dream at the time was to like do machine learning at like a real company that did like use machine learning for like important things to the company. So I worked on machine learning for fraud, which was great. But then at some point I was like, but I was really excited about this like infrastructure stuff, right? Like this networking stuff. And so I ended up switching to a networking team, where I did that and I had a lot of fun there.
Nice. So you were on the infrastructure team at Stripe, and at least if I don't remember the exact timeline, but I think sometime last year or the year before that, you started a business, Wizard Zines. I don't know if that's the right name, but at least the website is wizardzines.com, which I love. So you have been making zines way before then, though. So how did you come up with the idea of making zines in the first place?
I watched this movie called Girls to the Front, which is about zine culture, like Riot Girl and zine culture in the 90s. And I thought it was really fun, and it made me want to make a zine. And also, yeah. And I think I was giving a conference talk. And I thought it'd be so fun if I like wrote a zine and printed out 200 copies and gave it out to everyone at my talk. I was like, that would be so epic. So I did it, and it was really fun. It was exactly as fun as I hoped it would be. And so I ended up making a lot more zines because of that.
Well, that's awesome. So since you started a business, did you always knew you wanted to start one, or is this something that just happened organically?
I think it kind of happened. Yeah, I definitely didn't always want to start a business. I think I started one and then it worked and I was like, oh, that's cool. Maybe I'll do this for a while. But I was pretty surprised when it did work.
Well, it's awesome. We all love the zines that you make. So how's the experience been so far with running a business? I'm sure it would be very different from working at a company on an infrastructure team.
Yeah, it's very different. It's nice. I don't know. It's much more low key. And I definitely miss my coworkers sometimes. But it's also fun to be able to do like literally whatever I want in some sense, right? Like, so there's ups and downs.
Oh yeah, that certainly sounds nice. So let's talk about your blog a little bit. I remember reading a post where you mentioned why you started blogging when you were at Rickards Center, and we all are very thankful that you started it because we have learned so much from it. I don't come from a traditional CS background, so your blog has been a go-to resource for me to learn about a lot of the system stuff. Like whenever I see a tweet from you that you wrote about something, I get excited in the morning saying, oh, I'm going to learn something new today. So what I would like to know is, how did you decide that you wanted to write about so fundamental concepts and systems? I haven't seen that to be very common, but I'm glad that you decided to do it.
I think I wrote about those things because I didn't understand them myself. And I was kind of mad that, like, I think I write a lot from a place of like a frustration almost. Like, because I'll be like, this was so hard for me to learn and no one told me that it worked this way. And like, why not?
Yeah.
And I think a lot of those things inspire that feeling of like, why did no one tell me? And like, sometimes the things are not really that complicated too, you know? It's just that like the information isn't out there, or it's hard to find. So usually I just had a hard time and I want someone else to not have such a hard time.
Well, you have made lives of many engineers much simpler by writing all the posts that you do. So thanks for doing that. On top of that, I would say I really admire your writing style. I mean, especially the way you share your thinking. It very much feels like as if I'm talking to you live, even if I'm reading a blog post. And the way you explain things, it also shows up in your zines, making them so approachable. And a lot of it's very educational in the first place. So how did you develop this way of writing in general?
I don't know. That's a great question. I think, I don't know. I didn't always write that way. I don't know what happened actually. Cause I have this like master's thesis that I wrote on my GitHub profile somewhere, and it is not like that. Like, and then one sees that blah, 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 blah. And it goes on like that for 80 pages, you know? So I'm not sure how I got there. Like, I'm happy I did, but I wish I had a pithy answer. But I guess at least it's possible to learn, it seems like, and change. It
is. I mean, I look up to your writing style in many ways and thinking, oh, how can I make this simpler so that anyone reading it can just understand it? So another question also on your blog post is that your posts or your blog in general has a very positive and energetic personality to it. Was that intentional when you started blogging, or that just also happened organically?
I think when I started writing, there were a lot of things. Like, I was in a good place. I was at the Recurse Center. I got to learn a lot of stuff. And that's, like, a very positive environment anyway. And so, like, I didn't have a lot of, like, there wasn't, I don't know. That was just how I felt. I think, like, I've definitely been blogging for a lot of years. And, I mean, things happen that are not positive, in one's life. or in one's career. But one thing I like about writing in a positive way is it just makes it a lot easier kind of on the internet, because I feel like if you're negative, people are sort of negative back at you sometimes, if that makes sense. And so, like, just being like, here's something that I love. Like, because if I don't, there's lots of things I don't like, right? But I don't really write posts being like, here's why I hate, like, blah, blah, blah. Because I'm like, well, like, whatever. Yeah. There's enough posts like that, even though I have, like, lots of opinions. And I think I just find the conversations that those kind of posts generate to be more fun or, like, easier to deal with, right? And then no one is yelling at me being like, why do you hate blah, blah, blah? Because, like, they don't know. I only write about the things that I liked.
Well, that sounds like a good strategy. Since you mentioned about internet, I mean, internet is a funny place. And in your post, you actually mentioned that, hey, you don't know something. I think it's actually very brave. It's something that, well, I'm not always comfortable saying, not on the internet all the time. How did you get over that just barrier of saying, I don't know publicly? How do you get comfortable with that?
I feel like, I don't remember exactly. I feel like when I started doing it, I didn't think about it a lot. Like, I was writing every day. I was writing this blog post every day, and I was like, well, here's what I'm learning, And I think that the response was pretty good. Like, people liked it, And so I think I saw that it was okay to do that by doing it. And of course, some people will be like, oh, why don't you know this, right? But then also a lot of people will be like, well, people don't know things. Like,
yeah.
We are not all born understanding TCP. Like,
that is absolutely
I think it was
true.
also easier because I started out writing about a lot of things that a lot of people actually do not know about, Like, I was like, oh, I don't know how TCP works. And it's like, well, a lot of people don't know how TCP works, Like,
yeah. With you writing it on your post, it also makes me as a reader very comfortable just reading the post because I can relate to it so much. Okay, so this will be the last question on the blog because we have a bunch more interesting things to talk about. You mentioned in your About page that you have one opinion about programming. Can you share what that is and how did you come to develop that?
Yeah, so I said that the opinion is that if you learn if you want to do hard things, it's really important to learn the fundamentals. How did I develop that? I think I find it so fun to learn the fundamentals, first of all. Like I find, like, for example, like with TCP, right? Like, when you're going somewhere on the internet, it's so exciting to understand, like, what's actually happening while you're doing that. But I think that the place where learning fundamentals really, like, becomes important. And what I saw, like, in my career is if you're trying to fix a bug, or, like, which is what we're going to talk about. We're going to talk about bugs. And when you're trying to fix, like, a hard bug, you can't, like, it just becomes impossible if you don't understand the fundamentals, right? And, like, when people talk about debugging tools, sometimes they talk about, like, like, observability tools or, like, debuggers, and that stuff is really great and so important, and I love it. But, like, if you don't understand, like, the fundamental concepts about how the system works, it often is really hard to make progress. And the flip side is if you do, like, it becomes just, like, so much easier, right? Because you can think through in your head, like, okay, how should this work? Like, what are the steps here that are, like, happening on the computer? And it, like, gets a lot more straightforward.
No, that makes sense, and all of us relate to it.
Yeah, I would like to give Ronak some credit for smoothly transitioning that into a plug for our podcast. Well done, Ronak. So changing gears a little bit, one of the sort of quote-unquote misadventures we're talking about today is this post you made a little while back about why people should understand a little bit about TCP, which will include a link in our show notes. So you started the post being like, hey, these are practical tips. This isn't about reading through TCP IP Illustrated. when I read that, I gave myself a pat on the back for knowing what you were talking about. I actually have the volume 2 back there propping up my monitor. But I only know about it because when I was running into a lot of networking issues at my first job, trying to set up data infrastructure, my mentor at the time was like, hey, if you want to learn about how these things work, you should just go and read these books called TCP/IP Illustrated. Little did I know there's 3 volumes and each one is like 600 pages.
Yeah, I never read books. I haven't read any technical books. Which I think it's great I think it's great to read books, but I also think there's other ways to learn. And I mean, I have one book maybe that I read sometimes. But
thanks for making me feel better about never finishing TCP/IP Illustrated Volume 2. So for people like me who don't come from a traditional CS background and have never taken a networking class, but who also want to learn more about things like networking, these technical books can be quite intimidating. So I was really pleasantly surprised when I came across these networking zines you made, just at how approachable they are. And can you tell us more about that?
Yeah. So I think that for me, I find it a lot easier to learn by looking at, by like obviously learning some basic facts, but the bite-sized networking zine is about networking tools, and about like tools that you can use to inspect your network. And I find it a lot easier to learn by being like, okay, I want to learn about maybe TCP. I want to understand, like, for example, the other day I was trying to understand WebRTC because I was debugging a WebRTC problem with someone. And I didn't know anything about WebRTC. But I just like don't like reading books. Like I don't have the patience. So instead I was like, okay, let's look at some debugging output, right? Like let's set up a connection. And then it was like, oh, you have this like turn server. And then you can like find the port for the turn server, and then you can start capturing packets, like UDP packets, and then you can open up Wireshark, and then you can see the UDP packets that are being used to like start establishing this WebRTC connection. And I think that like trying to look at things interactively like that are really happening on my computer makes it feel so much more real to me. And like I'm sure that also it's not a lie. Like sometimes things that you read like on the internet are lies, or they're like not, or they're like true for someone else's computer but not true for my computer. And it just like so much more like it feels so much more like immediate and easy for me to understand when I can actually see like things that are happening on my computer.
That's awesome. So now jumping into the post itself, what was the team trying to do, and what was the problem that you guys saw?
Yeah. So we had this message queue that we were using called NSQ. And the way you publish a message to NSQ is there's a local like daemon running on every host that basically like so you send it a message and then it publishes the message to like some central place. And so what we were seeing was that publishing a message. So the way you publish a message is you make an HTTP request, right? Where you're like post and then you send the contents of the message. So that's super simple. We were doing that in Ruby. And someone noticed that it was taking 40 milliseconds to send each message. And I think I'd been learning about how much time things should take on computers around that time. And I was like, 40 milliseconds is too long for, an HTTP request on localhost to a Go program, right? Like this should not be, like, there's no reason it needs to take this long, right? It doesn't make sense. And I think we spent some time looking at garbage collection, and that was not it. Like the Go program seemed to be fine.
I see. And then you mentioned this blog post that you saw elsewhere that gave you a clue. Can you tell us more about that?
Yeah. So I'd read this blog post, I think the week before, that was like, hey, sometimes if you're seeing a slow HTTP request, it might be because of like a weird problem with TCP. And I think like my manager had posted it the week before, like coincidentally. And I was like, oh, that's interesting. That probably doesn't have anything to do with me, but it would be really cool if that was the problem, right? Because it would be. And so I think what I did, so I'll explain the blog post, and what it said. So what it said was that you can, in TCP, you send packets, and there are there are a lot of different ways TCP clients and servers can be configured. So one thing that the TCP client sometimes does is something called Nagel's algorithm. And what that means is it'll send up the first packet. And if that packet doesn't get ACKed right away, it'll be like, oh, there's a problem with the connection. Maybe I shouldn't send the second packet just in case there's some kind of like congestion, right? So it'll wait before sending the second packet. And then on the server, there's an algorithm called delayed ACKs, which is like, when I get the first packet, I won't ACK it right away because we don't want to like waste space on the network with ACKs or something. So I'll just wait until the second packet and then ACK that one. So the client sends the packet and it's waiting for the ACK, and the server is like, I'm waiting to send an ACK. Like I don't want to send too many ACKs or anything. And so they're both in this like kind of like stalemate until they time out after 40 milliseconds. And then the client just like goes ahead and sends the second packet. And this is something that's happening like inside the Linux kernel, right? Like at the OS level. And so it doesn't really, and I guess the other part of this is that the Ruby program was sending, like the request it was sending was quite small, but because of the way the code was written, it was sending the headers and the request body, the HTTP request body, in two separate packets. Which it didn't, like, if it had just been sending it in one packet, this also wouldn't have happened. So there was kind of like an interaction between like the Ruby code and the...
Interesting. In the post you mentioned using STrace helped quite a lot. I was curious what you saw there that helped you make the connection to the blog post.
Yeah, so what I saw there was you can see network packets being sent in STrace, I think with maybe send message. I don't remember the exact system call. But what I saw, what would I have seen? So you see the first packet being sent. And then you see the second packet being sent 40 milliseconds later. Yeah. And so I think, what I saw, because you can do strace-t to see timestamps. I think today I would probably use TCP dump for this, but at the time I was scared of TCP dump, so I used strace. Anyway, yeah, so you see one packet being sent and then another one being sent 40 milliseconds later. And then I was like, why? Right? Like, why wait to send the second packet? Like, what's going on? Is that true? Yeah, I think that's right. I honestly don't remember exactly what I saw. But it was something like that.
Got it. And why are you scared of TCP dump?
I think then I was scared of TCP dump because I thought,
I mean, I don't ever use it, but just curious from your perspective.
Yeah, so TCP dump I no longer think is scary. I love it. I think it's very straightforward to use. I wrote a zine about how to use it, which is free. It's on my website. if you want to not be scared of TCP dump as well. Because I was mad that it took me so long to not be scared of it. Anyway. But I think just at first, like, it's this command line tool. There's all these network packets. It prints out things that sometimes you don't understand, you know, like all of these things about like the TCP statistics. But the way I usually like to use TCP dump, which I find much easier, is you can capture packets with TCP dump and write them out to what's called a PCAP file. And then you can open them in Wireshark. And Wireshark I find much easier to use because it's like a graphical interface. You can see everything. You can filter things much more easily. And you can also kind of do it after the fact, you know, like you have like your data saved and then you can analyze it more slowly or maybe with a coworker or friend, right? And be like, okay, wait, what does this mean? And so I think I also learned that workflow, which I find a lot easier, than kind of trying to like use TCP dump interactively from the command line.
You mentioned TCP dump being scary at the time. I feel STrace is also scary. I mean, I've used it on occasions and it's extremely helpful, but I think it takes a little getting used to, and it's non-trivial initially when you're seeing a bunch of system calls and it's like, what does that system call do? So, like, one, how did you get just better at using STrace, and under what circumstances have you found it to be very useful as a tool?
So I think the real secret to using STrace is to ignore system calls that you don't understand, and to develop like a sense for like what system calls you do understand. For example, there's the open system call, which opens files, right? And that's like, okay, you know, it's not scary. And so when I'm stracing programs, often what I do is I'll, you know, just like grep for open and be like, I'm going to ignore everything else. I just want to know what files this program is opening. Or like if I'm looking at network stuff, maybe I'll be like, I just want to know like what it's sending and receiving. And then if there's like 3 billion other like few tags, like system calls.
That's the confusing one.
It's okay. Like that's not, and like often that's not the focus, right? So like often, One of my favorite ways to use STrace is if a program is like writing to a log file and I don't know what log file, and then you can just STrace the program, you find the file, it's over. You don't, like, it doesn't matter, like, all the other weird stuff it's doing, you know, you just need the file.
No, that makes sense.
Nice. Going back to the TCP issue that you guys were trying to solve. So once you made the connection to the blog post, did everything pretty much just work out from there on out?
Yeah, so I mean, we need to implement the solution still. So what I did was I set up this setting called TCP no delay on the client, which basically turns off the waiting for ACKs on the client side, because the client was the thing I had the most control over. And it was also what the HA proxy web blog post said to do. And then I like made this pull request and I was like, oh my God, like I've never like tried to change a TCP setting before. Like, is this going to work? I mean, like, it's kind of like scary because like if it doesn't work, I'll be embarrassed a little bit, you know? But I did it and it worked and I was like, oh my God, I'm amazing. Like, this is so cool. And I think the funny thing about this bug in particular is that over the years since I wrote that blog post, I keep on seeing people writing about it, being like, "This thing happened to me with Nagel's algorithm, like delayed ACKs," and I'm like, "Oh yeah, again." And I think it's just like maybe these are like very common settings that interact poorly, and it just keeps on happening. So I feel like it's like it wasn't like maybe a big coincidence that I'd seen that blog post. It's like just that this is like a relatively common thing, even though it seems like really obscure at first.
Was your team like, holy crap, like how did she know what to do?
I mean, maybe I think they were like, cool, good job. Like, and I really felt like validated because I was so obsessed with like networking and system calls, and that wasn't really my job at the time at all. And I was like, finally, like my obsession with these weird things has paid off. Like,
that's awesome. Changing gears a little bit. Something you emphasize quite a lot in your blog is the importance of learning the underlying systems that we use and rely on, which is definitely one of the core motivations that we have for starting this podcast. One challenge, though, sometimes is to figure out, okay, when do I need to dig deep into this concept versus, no, I just got more tickets I need to go do. Do you have a rule of thumb in terms of prioritizing what to learn?
Yeah. Especially at work. So I think one thing I think is important is if you're putting something into production and you're like on an SRE team, like I don't think it really works to put things into production that you don't understand, right? Like it's not okay. And so once a long time ago, I was trying to we were thinking about using Kubernetes, and no one on my team knew anything about Kubernetes, right? And so I spent a huge amount of time like trying to understand how Kubernetes networking works and just like being like, what is this thing? Like, how does it work? What's going on? I spent so much time like learning about like container networking and like namespaces, and like I think I spent weeks on it, and like in those weeks I really accomplished nothing at work. Like, well, I learned a lot. But I think at the time my manager understood, like he was like, hey, like we want to investigate using this technology. None of us know anything about it. So like someone needs to learn about it, And I think it was like understood that was a good use of time. Cause we did end up using it, and we did end up needing to use all of that knowledge to debug the problems we had. And so like, yeah, but I think that you do need to be in a place where like, that's valued, right? Which I think on a lot of infrastructure teams it is, because people see what happens if you have systems in production that you don't understand, and they see like where it leads.
It's a lot of fun when you get woken up in the middle of the night and something's not working, and you're like, I have no idea what to do now.
Yeah, exactly.
Well, I can't stress enough how important it is to understand the thing you put in production. Also, I empathize spending weeks learning about container networking. By the way, you have some really good blog posts on Kubernetes and containers. And for me personally, the ones on container networking and Kubernetes certificate authorities clarified so many things. And we'll link to all of these in the show notes as well. One of the posts around Kubernetes which you have is what we want to discuss today is on Kubernetes Scheduler, where you mentioned that you found a bug in production. Can you tell us what Kubernetes Scheduler does and what was the bug that you encountered?
Yeah, so I think I'll talk about the issue first because it was kind of, yeah. So we were running cron jobs on Kubernetes. And so I guess part of the model of Kubernetes is you have these things called pods. And it's like this declarative system where you declare a pod and you're like, hello, etcd, here's a pod. And it's like, great, there's the pod. But it's not running anywhere. And then so what the scheduler does is it periodically looks at the pods, and then it sees if one of them is not attached to a node and it's not running. And then if it's not running, it'll find somewhere to run it. And then it'll update it to say that it's running. Cool. And so we're running these cron jobs, and what running cron jobs means is that you're scheduling new pods a lot, right? Like if you're running like a web service where you just have some stuff running, maybe it restarts like every day, but we had like a lot of cron jobs that we were running all the time. And so new things were constantly starting. And, so we'd set up this cluster and we were starting to slowly roll it out, on some like less critical jobs. And someone on one of the teams that was operating these jobs, like that wrote the jobs, was like, hey, one of these didn't run that was supposed to run. What's going on? And I saw that it was stuck, and I restarted the scheduler, and then the pod ran. And I was like, okay, cool.
That's not supposed to happen.
That's fine that it's running now, but why, what happened? And I think I really had a choice. Like I could have let it go, or being like, maybe we should just restart the scheduler sometimes, I guess, right? But this was at kind of like an early stage of rolling out this system, and it needed to run jobs that were processing like a lot of money. And also, when there were problems with it, it caused a lot of problems for the engineers who wrote the jobs. And I decided, no, this isn't okay. I'm not going to accept, this happening. I'm going to figure it out. And so I didn't know how the scheduler worked. And I think the way that I assumed that it worked was that it looked at every pod periodically. It would be 4 X in pods. If pod is not running, then run it. Right.
That's what one would expect.
When I looked at the code, what?
I was saying that's what one would expect.
Yeah, that is what one would expect. And so I looked at the code, and that was not what the code did. Instead, what happened was that there was a queue, and that every time a new pod was added, it would get added to the queue of things to schedule. And if there was an error scheduling a pod, it would add it back to the queue of things to schedule. And this makes sense because you can imagine if you're trying to run 10 bajillion pods, you don't want to be iterating over all of them every single time, right? It could cause performance issues. So this is a really reasonable performance optimization to have this queue of things to schedule, and you only actually look at the stuff that needs to be scheduled. And then maybe you go look at everything again, when you're done. And so it turns out that what had happened was one of the pods, there'd been some error when trying to schedule it. And so it went off the queue, and then the error handling code was supposed to put it back in the queue, and it hadn't. And so I added maybe one line of code or something to put it back into queue, on this error. And to debug this, I think I added a bunch of console, or not console.log, but print statements to the scheduler, and compiled it and ran it in production or something to find it. I did something dumb like that because I was just so stuck, and I was like, look, what's another print statement? I really didn't have a plan. Anyway, so I compiled, I put in a fix, and then I compiled it, and I put it in production, and I saw that it fixed our problem, which was great. And then I made an upstream pull request, and it got merged. And then the problem never came back, and it was done. And it was so much nicer than trying to because you can paper over a lot of stuff in operations by restarting things. And it was so nice to not add to the stack of things that we'd papered over in that way. And there were other things that we did handle. We had a memory leak, and I could not figure out what was going on, and I just put just restart this sometimes. And that fixed the memory leak. And we never, I think eventually we upgraded it and it went away, but that one seemed kind of less important to me because it wasn't a correctness issue, But this one, I was like, no, I don't know. I was mad.
No, that makes sense. I mean, the importance of not letting weird things in production just go by and actually digging in, figuring out what exactly is happening to fix it for the long term. One thing which I will say is +1 to print statements. I'm sure a lot of people would argue it's not the best way to go about it. I can actually relate to it because a few months back, I did that exact thing to kubelet, compiled it, run it on a node to debug an issue. And I was like, I couldn't figure out anything else throughout the stack dumps I was getting. I was like, this is the best way. And well, we found the problem. It was our mistake, not a Kubernetes issue, but it worked. So +1 to print statements.
Yeah. I mean, you gotta do what you gotta do. And like adding a print statement is not that invasive.
Yeah. So the specific issue that you mentioned, how many was it happening too frequently, by the way? Like, were you seeing too many pods ending up in pending state?
It was not happening that frequently, no. Which was good in some sense, and it was like a nice example of why it's good to jump on stuff that isn't really a big deal, because this was not like an incident, but it would have been an incident like in the future, it's the kind of thing that like, you're like, if I don't deal with this now, I'm going to get paged in the middle of the night and
Yes.
people are going to be really mad in like 8 months,
No.
And
sense.
so I think I wrote like a whole post-mortem about it too, like be like, this is like what happened, like here's, just to show like the kinds of things that, because I think this was like one of the first Kubernetes issues we had, and I just wanted to show people like, these are the kinds of problems we're running into, and like this is what we need to understand about the system, so that when there are real problems in the future, we're like better equipped to kind of start dealing with them.
Yeah, that makes total sense. So you mentioned reading the Kubernetes scheduler code to actually figure out how it works, which is the right way to figure something out, but also navigating a huge code base, which is unfamiliar, and something like Kubernetes can be overwhelming. So what practices have you found useful when navigating such a code base?
I feel like a lot of grep, like a lot of looking for specific error messages, because I think I was seeing some weird error message in the log that was correlated with the error. So I was like, okay, that error message is related. So I think I tracked down like the code path that led to that error message, and I tried to like think about it. And like, what else is there? I also think that understanding kind of the overall architecture of the system is important, because with Kubernetes, at least at that time, and I'm sure now too, the components are like independent of each other. They run independently. So I knew that like the cron job controller was like a different piece of code that didn't like only interacted with the scheduler sort of through etcd. So I knew that I only really needed to worry about the code in like kind of the scheduler subtree of the Kubernetes. And I understood the overall system well enough to be like 100% sure that it was a problem with the scheduler. So I didn't like, because it sucks if you get like kind of distracted and you're like, oh, maybe it's in this component or maybe it's in this component. Like if you can tell from your model of the system, like, okay, the problem is here. Like even if here is kind of big, then at least like you can forget about all the other stuff,
Yeah, no, that makes sense. Narrowing down where the problem is, and anyone running software in production can attest that debugging is a very important skill, because things break almost all the time. Sometimes we are aware, sometimes we are not. And I loved your debugging zine. So what are some of the debugging practices you found to be useful? And did you pick up most of them at the job, or was it something else?
So what are the debugging practices that are useful? I think an important debugging practice is the practice of not giving up. Which is, I feel like one of the hardest ones for me sometimes, like especially if I'm in the middle of a problem and I'm like, why? Like maybe if I just run the same code again, it'll work. Like maybe it'll just go away. Like, like I find it still easy to succumb just kind of this like magical thinking of like, oh, maybe this problem will just disappear if I pretend it's not happening. So just like acknowledge that there's a problem and like believe in yourself that you can fix it or that you can find out. And then I think like what believing in yourself that you can fix it means is that like just like trying to find more information, like being like, okay, what information am I missing, and like how could I get it, right? And I think it's like that's not easy to do, right? Is to try to like A, like notice what information you're missing, and B, like figure out how to get it. Because sometimes the answer is like compile this thing. And, like sometimes getting it takes a long time, and you're like,
Yes.
Is it worth it? Like, but it's often worth it. It's like usually worth it to get more information. Also like talking to someone about like, hey, I'm in this situation. What more, like, how could I collect more information about this? Like, what questions could I ask about what the system is doing? And yeah, because that's all it is, is like collect information. And then eventually, once you have enough information, you understand what's happening.
Yeah, that makes sense.
I think for me, debugging gets like emotional sometimes. I try to catch myself when I get stuck in this loop of asking myself, wait, but this should work, but why doesn't it actually work? And then just really stop that thinking and be more matter of fact. Like, hey, I've checked A, B, C, I haven't done D, even though that seems obvious, but let's just do that. But yeah, I think just not giving up is hard, but really important.
Yeah. It's so emotional. Like, it's so stressful sometimes. And it's like, I don't know, I find it a really intense process, especially when it's a really complicated system that you're trying to reason through. And like, there's so many things in your brain. And like, sometimes there's pressure from other people. Like, and I think it's important to acknowledge that it's kind of an emotional process and to be like, okay, let's calm down.
Yeah, and it's a range of emotions. I mean, starts with some frustration, maybe gets stressful at times, but debugging can also be a lot of fun. I mean, I know I have learned the most about a system when it's not working the way it is supposed to. And when you actually don't give up and eventually solve the problem, it is so gratifying that you were able to get through all of that and fix the problem.
Mm-hmm. Yeah, it feels so good. And then I think that really helps feed into like future problems, because then you can be like, okay, this is really hard and I have no idea what's going on, but remember when I solved that really like hard bug that other time and it took 5 days and I got it and it was amazing, and like this is going to be like that.
Yeah.
And I think you can like hold on to those things after, and they can bring you forward in future bugs.
To wrap up, I saw on your blog that you've been looking into autoencoders and using it to cluster faces, which I thought was pretty cool.
Oh, yeah.
I'm curious how you're picking new topics to explore now that you have a lot more freedom and control over your time.
So I think the autoencoder neural network thing is like, I was just mad that I don't understand what's going on with neural networks like at all. And so I was like, let's do a little like fun project to try to understand. Because I wrote this, I read this paper like 4 or 5 years ago that was about how to trick neural networks. Like how to trick like an image recognition algorithm into being like, thinking like a panda is a vulture or something. Like you can take an image of a panda and like modify it a little bit to convince it that it's a vulture. And yeah, you just change the pixels a little bit, like by like 0.01 or something. And then you can trick it into thinking it's any other animal you want. Anyway, I like found that so cool at the time, but I still came away from that having like really feeling like I didn't understand anything about these neural networks. And I don't know, I think a lot of us want to know what's going on. So and just trying to understand like, 5% more for myself.
Cool. So the fun question that we like to ask is, what was the last tool that you discovered and really liked?
I think the thing I'm learning right now that I'm really into is Rails, which I'm finding really fun. And it's really different from, like, usually I like things that are, like, very explicit and, like, where you know where everything is coming from. And Rails is really the opposite of that. But I'm having a lot of fun with it anyway. And it's nice. And it's nice that it's, like, such an old technology, Like, I was watching DHH's video about it from, 12 years ago, 2008. And I'm like, oh, wow, yeah, this is really cool. So...
What websites are you building?
Right now I'm building a website that gives you a virtual machine, like an AWS instance or something, and is like, something is wrong on this computer, like figure out, or it tells you like something specific that's wrong, and then you have to like figure out what it is. And so it's like a pretty simple website. because it's probably more about like designing like problems to show to people that are fun. But you also need to like let people log in, like blah blah blah, and like manage the instances. So yeah, so I'm running a website and I'm using Ruby on Rails, and I'm really having a fun time.
Oh, I would say that's actually a really cool idea. It reminds me of something we used to do at one point, like Wheel of Misfortune. I think Austin came up with that term. Where we would like break something intentionally on a system and like give each other a problem to figure out.
Yeah. That's so fun. Like,
it's good when you can do it in a controlled environment.
Yeah, exactly. Because so many of these things, like, it's so stressful to find it out, like, during a production incident to learn this stuff, or to, like, learn some of the tools. Like, you don't want to be learning about STrace for the first time, like, when you're trying to, like, when, like, the site is down. Like, it sucks. And so, but it's, like, it can be so fun to, like, actually deal with these problems if there's not that stress. And so I wanted to come up with, like, a more fun environment for learning about some of the stuff that you learn during real incidents.
Nice. I'm looking forward to when you release that website. And thank you so much for taking the time, Julia. It has been awesome talking to you. We really appreciate you joining us today.
Thanks for having me. This is really fun.
Hey, thank you so much for listening to the show. You can subscribe wherever you get your podcasts and learn more about us at softwaremisadventures.com. You can also write to us at hello@softwaremisadventures.com. We would love to hear from you. Until next time, take care.